What is supervised learning? Supervised learning is a type of machine learning algorithm where a model is trained using labeled data to make accurate predictions or decisions. It involves a clear mapping between the input variables, features, and the desired output variable, target. Supervised learning is a type of machine learning algorithm. It uses labeled data to make predictions or decisions. There is a clear mapping between input and output variables. In supervised learning, a model is trained using a labeled dataset where the input features and target variable are known. The model learns patterns and relationships between the features and the target variable during the training process. Once trained, the model can make predictions or decisions on new, unseen data. Supervised learning requires labeled data for training. The labeled data serves as examples for the model to learn from and understand the underlying patterns in the data. It helps the model generalize and make accurate predictions on new, unseen data. Types of supervised learning algorithms. Regression. In this type, the target variable is continuous and the algorithm learns to predict a numerical value. Example, predicting house prices based on features like location, size, and number of rooms. Classification. Here, the target variable is categorical, and the algorithm learns to classify data into different classes or categories. Example, classifying emails as spam or ham based on their content and characteristics. Nearest neighbors. This algorithm finds the similarities between data points and uses the labels of the nearest neighbors to make predictions. Example, recommending similar products to users based on their purchase history and preferences. Advantages and limitations. Advantages. Limitations. High accuracy when trained with sufficient labeled data. Ability to handle complex problems and large datasets. Applicable to a wide range of domains and industries. Dependent on the quality and representativeness of the labeled data. Requires human experts to label the data, which can be time-consuming and expensive. May struggle with unbalanced datasets or outliers. Supervised learning offers several advantages, including high accuracy when trained with sufficient labeled data and the ability to handle complex problems and large datasets. However, it also has limitations, such as its dependency on the quality and representativeness of the labeled data and the need for human experts to label the data, which can be time-consuming and expensive. Conclusion. Supervised learning is a crucial aspect of machine learning that allows models to make accurate predictions or decisions based on labeled data. By understanding the concepts and types of supervised learning algorithms, one can harness this powerful tool in various domains and industries. What is supervised learning? Supervised learning is a machine learning technique where an algorithm learns from a labeled dataset to make predictions or decisions based on the patterns it identifies. It involves training a model using input-output pairs to predict an output when given new inputs. How does supervised learning work? In supervised learning, a model is trained by providing it with labeled training data. The model then learns the relationship between the input data and the corresponding output labels. Once trained, the model can be used to make predictions or classifications on new, unseen data based on its learned patterns. What are some examples of supervised learning algorithms? Some commonly used supervised learning algorithms include linear regression, logistic regression, decision trees, support vector machines, and neural networks. What is the difference between supervised and unsupervised learning? The main difference between supervised and unsupervised learning is the presence of labeled data. In supervised learning, the algorithm is provided with labeled data, while in unsupervised learning, the algorithm works with unlabeled data and aims to find underlying patterns or structures without a predetermined outcome. How do I prepare data for supervised learning? To prepare data for supervised learning, you need to ensure that your dataset is properly labeled and that the features are well defined. It is also important to handle missing data, normalize or standardize features if necessary, and split the dataset into training and testing sets for evaluation. What are the limitations of supervised learning? Some limitations of supervised learning include the need for labeled training data, the potential bias introduced by the labeling process, the assumption of independence among features, and the inability to handle new or unexpected input patterns that were not encountered during training. Can supervised learning be used for regression and classification tasks? Yes, supervised learning can be used for both regression and classification tasks. Regression tasks involve predicting a continuous output, while classification tasks involve predicting a discrete output or assigning data to predefined classes. What is overfitting in supervised learning? Overfitting occurs in supervised learning when a model becomes overly complex and starts fitting the training data too closely, resulting in poor performance on new, unseen data. This usually happens when the model captures noise or outliers in the training data instead of the underlying patterns. How do I evaluate the performance of a supervised learning model? The performance of a supervised learning model can be evaluated using various metrics depending on the task. Common evaluation metrics include accuracy, precision, recall, F1 score, mean squared error, MSE, and mean absolute error, MA. What are some applications of supervised learning? Supervised learning has a wide range of applications, such as spam filtering, sentiment analysis, image recognition, credit scoring, medical diagnosis, recommendation systems, and speech recognition.